Hello, this is Mr. Huber. In this lesson, we're going to learn about graphing linear equations using slope-intercept form. Slope-intercept form is called that because the two key pieces to it are the slope and the y-intercept, things that we've seen and are familiar with. Okay, slope, right, is rise over run. We represent that with an m, rise over run, and we find the change in the y's, the change in the x's. Key things as well to remember about slope that we've already seen. Keep it as a fraction, right? You want to have slope as a fraction. Don't turn it into a decimal, but reduce the fraction. Positive slope is a line that's going up to the right. Negative slope is going down to the right. And if you have the numerator or denominator negative, then the slope is negative. If you have them both negative, remember, a negative over a negative gives a positive value, right? Negative over negative is a positive. So keep that in mind as we work with slope. In our special cases, if you will, the horizontal and vertical lines. So a horizontal line will have a slope of 0. It's 0 over something. Okay? When the denominator is 0, that is undefined. And a vertical line will have a denominator of 0 and a slope that's undefined when we calculate slope. The intercept part, okay, as I mentioned, it's the y-intercept. That's the point where the graph crosses the y-axis. We're going to see that's a key piece to a linear equation in slope-intercept form. And that x-coordinate will always be 0. So it's going to be 0, comma, some y value for where that y-intercept is for the graph when we go to graph it or read it from a graph as well. And y-intercept is represented by the letter b. So slope is m, y-intercept is b, and let's see what that looks like in slope-intercept form. So we see here what that looks like in slope-intercept form. This is slope-intercept form right here. Okay, this is slope-intercept form. Y equals mx plus b. We want to get the equation solved for y in terms of x, or as a function of x. It's down here. We must have the equation for y as a function of x, or y by itself equaling some mx plus b, where m will be our slope and b will be the y-intercept. This is slope-intercept form, using the slope and the intercept, the y-intercept. If we use this equation as our example, this graph, okay, this has a y-intercept of 1, right? 0, comma 1. So my y-intercept is 1. The b value is 1. The slope, rise over run. So we go up 1 over 3. 1 over 3 is the slope, so we'd have y equals 1/3 x plus 1. This equation would be the equation that gives us this line. Any point on this line we could plug in, it would make this equation true. Remember, that's what a graph is. It's all the points, all the ordered pairs that make this equation true. So y equals mx plus b, slope intercept form, and this is what it looks like with a couple numbers in there. Always get the y by itself. So let's see what that looks like in practice. Try some examples here. We want to identify the slope and y-intercept of these lines. We need to get them in slope-intercept form. We have to get the y by itself. So in this first equation, we have 3x minus 3y equals 12. So first we should subtract 3x on both sides. Right, we're trying to get the y by itself. Of negative 3y, don't forget to bring that negative sign down, equals negative 3x plus 12. You could write that as 12 minus 3x, but it's better here to start putting the term with the x first, because that way we have the mx and then the plus b. And now we want to divide everything by negative 3, everything by negative 3, and that's going to give us y equals negative 3 divided by negative 3 would be a 1x minus 4. 12 divided by negative 3. We don't have to write the 1 here, you can, but if we see a variable with nothing written in front of it, we assume that's a 1 as a coefficient. Okay? So my slope in this line would be a 1. My y-intercept would be a negative 4. So identify the slope and intercept. Now that we have it in slope-intercept form, y equals mx plus b. The m is 1, the b is negative 4. Right, so let's write that out. Here, the m equals 1, the b equals negative 4. That would be my slope and my y-intercept for number 1. In the second example, we want to do the same thing to get the y by itself. Here we're going to subtract x on both sides. That will cancel out, and we'll get 4y equals negative x plus 6. And now I want to divide by 4. Divide everything by 4. That will cancel out and give me 1y, which is I want, equals negative 1 over 4 x plus 6 over 4. Okay? So the negative 1 over 4, right, just keep it as a fraction. We don't need to turn anything else. So my slope here would be negative 1/4, And my b, my y-intercept, I can reduce that to 3 over 2. The 6 over 4 can reduce to 3 over 2. So now I've got an ability to take these equations, solve them for y as a function of x, or in terms of x, and then when I have y equals mx plus b form, I'll be able to read the m, which is my slope, and the b, which is my y-intercept. Now let's actually draw a graph of this. After we get this in slope-intercept form, let's see what the graph would look like. So I can take this equation, and again, I'm going to solve for y, so I'm going to subtract 2x on both sides. And we get negative 5y equals negative 2x plus 10. And then I'm going to take that and divide by negative 5 on both sides. Cancel out, gives me 1y equals negative 2 over negative 5 is a positive 2 over 5x. We can just keep it as a fraction. And then 10 divided by negative 5 would be negative 2. So now to graph this, okay, and we'll use a scale of 1 when we go to graph these, okay? So I can take this now, and what I'm going to want to do is plot the y-intercept, okay? And that was negative 2, so that's my y-intercept right there. And then I want to use my slope, and if you recall the slope here, go back real quickly. The slope was 2 over 5. So I'm going to take this and I'm going to go up 2 and over 5. So from this point, I go up 2 and over 1, 2, 3, 4, 5. So I'm going to point right there. Okay, that's going to be my other coordinate that then I can draw my line through. And I can go up 2 and over 5 again. Okay, so from here I go up 2 over 5. I could go down 2 and left 5 because negative over negative is positive. I'd have that same line. And now I could draw a graph through those points. And I've got my line graph. That's my y equals 2/5 x minus 2. Slope m, 2 over 5. B value, okay, of negative 2. So after we get that in slope-intercept form, we can use the slope and the intercept. The first thing you do is plot the y-intercept. Okay? First thing you do is you take this y-intercept and you make a point right there where the y-intercept would be. And then you can use the slope to find a second point. And a third point, as many as you want, at least 2, to be able to draw your line through those points. Diversion from our linear equations here. A mammal that has knees that face backwards. It might not even be something that you typically think of when you think of a mammal. It's a bat. Bats are mammals, and their feet and legs are entirely rotated, facing backwards, their feet and their knees. It helps for lots of reasons. It helps the way they hang there because the way the tendons are, they can just grip on and they can relax. They don't have to put any effort in. They can just sleep hanging upside down. Helps with their flight for landing. Okay, when they land and their knees face backward, the way they land helps them out a lot. And also, the way that their wing structure is with their feet, the way they face backwards, they can help with the wings to form the membrane structure that helps them in flying and actually catching bugs as they fly as well. So bats' feet, knees that face backward, quite beneficial to them for many reasons. All right, back to some linear equations. Parallel lines are lines that never intersect, and they will always have slopes that are identical, that are exactly the same, equal to each other. Okay, parallel lines will have slopes that are equal. There'll be lines that are the same distance apart and never cross each other, never intersect. So let's look at this graph in number 4 and determine if any of the lines are parallel. To find slope in this case, since we have a graph, we can just count the rise and the run. So we can take this and rise and run. And so for that blue line, I've got a rise of 1 and a run of 3. So I'd have 1 over 3 for my slope. For the red line, I can count a rise up 2 and over 5. So I got 2 over 5. And for my green line, I got a slope that's rise 2 and run 6, which might not look like I have slopes that are identical, but 2 over 6 can reduce to 1 over 3. We always want to reduce slope, and we see the 1/3 and the 1/3, those slopes are identical. So the blue line and the green line in this case would be parallel because they have slopes that are exactly equal. Now let's calculate some slopes to see what lines are parallel using coordinates and using our y2 minus y1 over x2 minus x1. So for line A, the slope is going to be 4 minus 2 over 3 minus negative 1. So that's going to be 4 minus 2 is 2 over 3 minus a negative 1, right? Subtracting, that means we're adding, so 3 plus 1, which is 4. So that's a slope of 1/2. So line A there would have a slope of 1/2. Line B, right, has the point 2 comma 2 and 5 comma 8, so that's my slope of y minus y over x minus x. That's going to be 6 over 3, which is 2. And then line C, my slope is going to be 1 minus negative 2 over negative 3 minus negative 9. So 1 minus negative 2 is a positive 3. 3 minus a negative 9, so 3 plus 9, which is 6, which is 1/2. So those two slopes are equal. 1/2 and 1/2 are the same slope, so line A would be parallel to line C. Okay? Line A and C, that symbol between them, that's little slanted parallel looking lines, that's a symbol for parallel. We can say that A is parallel to C because they both have a slope of 1/2. Same slope, the lines will be parallel. Let's see what a linear equation in slope-intercept form looks like in some kind of real-world context. So we have a company that made two 30-second commercials. It costs a different amount of money to make each one. One costs $300,000, the other $400,000. But anytime they air it, doesn't matter how much it costs to make it, the airing of it is the same for each commercial, $150,000 to air that 30-second commercial. And we have equations for these two situations. The first one is 150N plus 300. These are in thousands of dollars. So this is 300,000. We're just using a 300. We're knowing these numbers are in thousands. Okay, and the second commercial is 150N plus 400,000, right? Because they each cost a different amount to make, but the same amount to air n number of times. So it airs once, 150,000 times 1. Airs 10 times, 150,000 times 10. Let's graph both these equations in the same coordinate plane. One thing to keep in mind here when you're setting up your graph, we are not going to need negative values. You're not going to air the commercial a negative number of times. It's not going to cost a negative amount of money to air it. So when we set up our graph, we just need the first quadrant. Air it some number of times and get out a C value, a cost. So N is the input in this case, right? That's our horizontal axis. So we see what it's going to be like to air it once, twice, 3, 4, maybe go to 5 times here. And let's go by 200s on my vertical axis. Okay. And this should give us reasonable grid to be able to draw our graph on. Okay, so let's see what that looks like. This first equation right here, right, 150N plus 300. So we start at 300, that's our y-intercept. So when you graph, right, a slope-intercept form, always start with the y-intercept and now use our slope. 150 is 150 over 1. So I'm going to rise 150 and run 1. So if I go up 150, I'll be at 450 and then over 1. That's 450 about. Then I go up another 150, that's going to be at 600 and over 1. Then I'm going to go up another 150, that's going to be at 750 and over 1. And then up another 150. So 750 plus 150 is going to be 900 and over 1. All right, so if I aired this 4 times, I could put a 4 in here. 150 times 4 is 600, plus 300 would be 900. So again, we're kind of estimating a little bit, 900. That's my graph. Looks like this, and I can draw a line that goes through those points. Okay, drawing it by hand, so not exact, but if you have grid paper and you're doing a decent job, right, you'll get an idea. The graph be a little more exact, the more exact your grid is if you're doing it on. So now I'm going to graph the second equation. So that's this one right here, 150N plus 400. So I'm going to start at 400. I'm going to go up 150, that's at 550, and then over 1. Another 150 will be 700 and over 1. Then up another 850 and over 1. And 850 plus 100 would be 1,000 and over 1. And I'm going to get a graph that looks like this. And we should notice those graphs look parallel because they are. They have the same slope, right? These are never going to intersect. They're the same distance apart the whole time. So here it says, what's the difference in cost to produce a commercial that airs 2 times or 4 times? Okay, so if it air it 2 times, there's a $100 difference. I could read those numbers from my graph, which maybe isn't exact, or I could just go up here and put a 200 in each of these. So if I put a 2 in here for airing it 2 times, 150 times 2 is 300, plus 300 is 600. 150 times 2 is still 300, but plus 400 now is 700. So it's always going to be 100 apart. This part's never going to change, but I'm going to add in 100 more this second time. So these are always going to be 100 apart, or in this case, in thousands, 100,000 apart. So that's what something looks like in a real-world situation, but no different from a y equals mx plus b, c equals mn plus b. Our y-intercept, graph your y-intercept, then use your slope, rise over run, to get some more points, and you can draw your line through them. So y equals mx plus b, slope-intercept form, because it uses the slope, the y-intercept, those key features we want to look for, get the y by itself, read the M, read the B. You can get the information you need to draw a graph, or you could even read that information from a graph. So slope-intercept form, y equals mx plus b.